Use the unit circle to look at the cosine of the cosine graph in more detail. So again, if you remember our unit circle, the cosine is the adjacent side. The length of the adjacent side is the cosine of the angle. So in this example, for 60 degrees, the cosine of 0.5. The length of the purple side is 0.5. So let's look at what happens as we move through the graph. Now again, we're plotting the x-axis is our angles. So as we increase the size of the angle, the cosine of the angle changes. So starting here, the cosine is the full width of the radius, which is 1. And as we go into bigger angles, you see in that triangle on the left, the adjacent side is smaller, or the sine of the angle, the cosine of the angle is getting smaller, until when we hit 90 degrees, there is no width. It's not a triangle, so there's no width. Then as we go into negative coordinates, we're going into the left, so the x coordinate is negative. We go to -1, the cosine starts going down to negatives. Now it's going closer to 0 again, but it's still in negatives until we hit 0 there. And then we're starting to look at positive x coordinates again, positive x values. So the width is positive here, the cosine is positive until we get back to 360. So one full revolution of the circle traces out a graph that starts at 1, comes down to -1, back up through 0 and up to +1. And if you look at both the width of the purple line on the left of the triangle, the adjacent side of the triangle, and the graph on the right hand side. So it starts out at 1 and moves back to 0, through 0 to negatives, and then back